Oh, well, hello there. My name is Miss Townsend, and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying quadratic relations. It's a video where I look at some word problems, and they're the word problems where I don't give you the equation, but rather you have to create the equation out of the information provided. So from a worksheet I've handed out, this is question number 6. It says, three consecutive integers are such that, oh, wait, I skipped a word. Three consecutive even integers are such that the product of the first two is 6 less than 9 times the third. So, and then find the integers. So certainly this is a mouthful. Let's worry about that later. Instead, let's concentrate on what three consecutive even integers looks like. So give me any three consecutive and even integers. So for example, that's three consecutive even integers. Or this is three consecutive even integers. Or this is three consecutive even integers. So they're integers that are even, and they're the three that would show up in a row if you were to ignore all the odd numbers. So this is what three consecutive even integers looks like in general. Nope. Specifically, here's three examples. What does it look like in general? So if I start here, and we'll say make this even. So we're going to say that can be even only. No odds allowed. Um, what would the next one look like? Would it be x plus 1? No. X plus 1 would be an odd number. So for example, if this was 6, the next one would be 7. We don't want x plus 1. What we need to do is skip the odd numbers and say here is even, skip the odd, even, skip that odd, even. So this is what three even consecutive integers looks like. So let me put another example up for you. See, if I start here, if I start with 6, if I add 2, I have my next even number. If I add 2 to that, I've got my next even number. So adding 2 to adding 2 is where add 4 comes from. So this is what three consecutive even integers are going to look like. And again, we have to include this little piece of information here, the fact that it must be even only. In university math, yeah, why are we talking about university math? We're in grade 10. In university math, you would not define it as x and say it must be even. You actually do something a little sneakier. And just for kicks, I'm going to show you what you do. You would actually define x to be a number like this, where k is any integer. Because then pick any integer you want. 17, good one. 2 times 17 is an even number. Pick any other integer. Negative 12, good pick. 2 times negative 12 is also even. So, you know, higher level math, you can't get away with saying let it be x and x must be even. You have to be a little more careful. But, you know, we're just in grade 10, miss. Okay. So now that we know what even consecutive integers look like, let's go ahead and start writing a proper solution. And again, that starts with let x be, and for consecutive stuff, we always say the smallest integer. And therefore, the other integers are x plus 2 and x plus 4. So we only have defined one variable. We're not defining an x and a y, or even worse, an x, y, and a z. We only have one variable, so we're only looking to create one equation. And that equation comes from the rest of the words in this sentence. It says the product of the first two. Well, product means multiply, and the first two, I assume, means the first two when you write them as consecutive integers. So the product of the first two means take the first one times the second one. Is, well, is usually means multiply. 6 less than 9 times the third. So 9 times the third looks like this, and I need 6 less than that. So see what I did? I slowly, carefully, the product of the first two, is 6 less than, and remember, less than always kind of goes at the end, 6 less than 9 times the third number. So there's my single equation based only on one variable called x. So now we have only to do the math. So we're going to do multiplications and collecting like terms and so on. And presumably we're going to get a quadratic out of this. So first of all, I'm going to multiply x into this bracket. So x squared plus 2x. Over here, I'll multiply 9 into this bracket. 9x plus 36. And there's a minus 6 here. So I'm going to have x squared plus 2x equals 9x plus 30. And then let's move everything to the left so that it equals 0. X squared minus 7x minus 30 equals 0. So there's my quadratic equation, and it equals 0. So at this point, you can either use the quadratic formula, or you could try factoring. Now this one is going to be really easy to factor, right? It's a simple trinomial, two numbers that multiply to 30 and add to negative 7. Multiply to negative 30, add to negative 7, negative 10, positive 3. And again, x times x is x squared, plus 3x minus 10x, plus 3 minus 10, boom, negative 7. And negative 10 times 3 is negative 30. So there's my factored equation, and now I have something times something equals 0. So if this is equal to 0, I have a solution. Or if this is equal to 0, I have a solution. What value of x makes this 0? If x is 10. So there's one possible solution. Or what value of that makes it 0? Negative 3. So there's another possible answer. Now, again, remember that x is an integer, which means there's no reason to cross off negative 3. It possibly is a very perfect answer. So if x was 10, what would my numbers be? Well, I would have 10, 12, and 14. If x was negative 3, now hold on. Didn't I say, or mean to say, that x must be even? Oh boy, my eraser just went crazy. Okay, so remember, x must be even. I should have explicitly said that at the beginning, but hopefully you remember to do that. And therefore, that's why I can say inadmissible. Not because it's negative, but because x was supposed to be an even number. So 10, 12, and 14 is my only possible solution. Let's check. If I take the product of the first two, is that equal to 9 times the third minus 6? Is that a true statement? So here I get 120. Here I get 9 times 14 is 126. Well, look at that. It works out perfectly fine. So I'm content that I have the right answer. So I will finish by saying, therefore the numbers are 10, 12, and 14. And remember, this was inadmissible because it was an odd number, and the question said I wanted an even number. So that's question number 6, and maybe I'll see you at the next video. Bye for now.